All right, we have now finished Unit 3, and we will be reviewing today and tomorrow as we approach Halloween. I hope everyone's enjoying our Halloween Spirit Week this year. I actually spent the weekend trying to get my kids' costumes in order that I still need to work on mine, but I hope you're going to be joining us in the dress-up day on Thursday and Friday. It would be great pictures for yearbook, so go all out, go crazy. All right, so I am going to be doing the evens on today's review pages. Hopefully you tried the evens and now are using the video to check your answers and fix and correct your mistakes if there are any. Hopefully you're doing it in a different color ink so that you have an idea on where you need to practice and study and don't have to go back and rewatch and study all 8 lessons. So I suggest using a different color so that you understand and learn from your mistakes and go back and watch whatever area you're having issues in. So for example, up at the top, this is lesson 1. It's not numbered, so I'm going to go through the vocabulary here with you, but anything that has an even number should already been done and tried by you and then checked with this video. So lesson 1, define and following and give an example of each. So monomial is one term. So for example, 3xy squared would be one whole term because there's no addition or subtraction signs. Binomial, 2 different terms. And for example, 3x squared plus 2x, even though both terms have an x, the first one has a squared and the second one just has the letter x. So those are not like terms because they do not have the same exponent. So that would be a binomial. That is 2 different terms. Problem number 3, trinomial. Vocabulary word number 3, trinomial, is 3 different terms. And for example, that would be 3x squared plus 2x, and let's put a constant on here, plus 6. Those are 3 different terms that you cannot combine together, so that would be a trinomial. Polynomial, poly means many, so polynomial means many different terms. So anything more than 3 terms we would call a polynomial. Binomial and trinomial are also referred to as polynomials. Poly is like the umbrella word for bi and tri, but anything more than 3 you would just reference as a polynomial. We didn't spend too much time with anything longer than 3 terms in this unit though. State the operation represented by each. So sum would be the answer to an addition problem, so I'm going to put a plus there. Product is the answer to a multiplication sign, so multiplication problem, so I'll put a multiplication sign. Quotient is division, which the last lesson I told you to use a fraction bar for. And difference is the answer to a subtraction problem. So this is now filled in, whether you did it or not before the video, it should be filled in regardless. And now for the remainder of the video, I am going to go over the evens, which should have been done. So again, each section is labeled with the title of the lesson that it goes with. So if you find that you're getting a bunch wrong in a particular section, make sure you go back and rewatch the lesson video that corresponds to that section. So number 2, classify each of the following as a monomial, binomial, trinomial. I'm going to use M for monomial, B for binomial, and T for trinomial. On the test, if it's required for you to answer a question like this, you do need to write the full word. 2a, 9x plus 3y, those are 2 different terms that I cannot combine together, so I'm going to put B for binomial. 2b, that is one whole term, there's no addition or subtraction, that is a monomial. C, we have a constant of -2 with no variable, that is a monomial. D, again a constant, no variable, that is a monomial. E, all multiplication, no addition or subtraction, that is a monomial. And then F, we have 14x, a positive 4y, and a -3, 3 different terms, that is a trinomial. Number 4, simplify each expression, which means you want it in the most reduced form possible. I have a 2x and a 1x. Remember, if it doesn't have a coefficient, give it a 1. 2x plus 1x, my most simplified form is 3x. So again, this is not a binomial because I was able to combine those. So 3x is a monomial. So you always want to check to see if you can simplify before answering any questions about the problem that is given. Number 6, I have a 3x and a positive 5y. Those are two different terms that I cannot combine together. So I'm just going to rewrite what I have because that's the most simplified form. Number 8, we have decimals. So when I go to combine my 5.6x and my positive 9.1x, I hope you used a calculator. But if you don't have a calculator handy and you did it by hand, you want to make sure when adding and subtracting decimals, you line the decimals up. Since it's addition, it doesn't matter in what order I add them up in. So I add up my tens place, which is 7, and now I add up my ones, which is 14. So 14.7x. Plus the 2, and it stays like that, so it is a binomial. And again, you could just do 5.6 plus 9.1 for those that have the calculator at home. Number 9 is an odd, so I am not going to do that until tomorrow. Lesson 2, so again, if you get any wrong in this section or you find you're getting many of them wrong in this section, you can go back and watch lesson 2 video. So number 10, again, simplify each expression. So I'm going to start by combining like terms. Signs are different, I subtract, or just do negative 8 plus 8. These are additive inverses. You get 0. Do not write 0x because 0 times x is 0. Number 12, you have fractions. So again, hopefully you have your calculator handy, but if not, I'll show you how to do it without one in case you don't have it next to you. So when you're dealing with fractions, you want to make sure you get a common denominator when adding and subtracting. So since my second mixed number has a denominator of 9, I'm going to make my first fraction have a denominator of 9 by multiplying by 3. And whatever you do to the denominator, you have to do to the numerator. And again, this is not necessary if you have a calculator. So my new fraction is now going to be negative 3/9. And now that my fractions have the same denominator, I now can add them together. So negative 3/9 and a negative 3 4/9, signs are the same, I add. So it will be a negative 3 7/9. Those of you that do have a calculator, you're going to do negative 1 ABC3 minus 3 ABC4 ABC9 and let it compute the answer for you. Don't forget to put the x next to that mixed number. And then I have a positive 9 and a positive 10, which gives me a constant of a positive 19. Number 14, we need to distribute first to simplify the expression. So I'm going to take what's on the outside and multiply it to what's on the inside. So 3 times 5x is 15x. 3 times 1 is a positive 3. These are not like terms, so my answer is 15x plus 3. Number 16, there's no number to distribute. However, there is a negative there, so I'm going to put a 1. Negative 1 times 7x is negative 7x. Negative 1 times 4 is negative 4. So when there's a negative on the outside, it changes everything in the inside to its opposite. Or again, you could just use that calculator and do negative 1 times 7, negative 1 times 4. Number 18, again, just the minus or negative on the outside. So I'm going to put my invisible 1 in. Negative 1 times 8 is negative 8x. Negative 1 times 9 is negative 9. Number 20, 1/2 times 20, or half of 20, is 10x. 1/2 times 10, or half of 10, is 1. No, 5. Half of 10 is 5, not 1. So 10x plus 5 is my answer. And again, hopefully I'm not going too quick for you, but this should be done already. You should just be checking and pausing and rewinding based on what you need to fix. Number 22, find the area of the rectangle. So in order to find the area of a rectangle, it is length times width. So I'm going to take my width of 5 and multiply it to my length, which is a binomial. And I want to multiply my 6 by 5 and my 7 by 5. So I'm going to use the distributed property. I get 30x minus 35 as the area in terms of x. Lesson 5 and 6, we covered the greatest common factor. We did use tables, prime factor trees. I did show you a shorter method as well where I take the smaller of the two values, so in this case 20, and I write down all of my factors of 20. So 20 can divide into 20, 5 can divide, 10 can divide. Work from the biggest down, so biggest to smallest. So 20 can go into 20, 10 can divide into 20, 5 can divide into 20, 4 and 2. Now I use my factors of 20 to figure out what greatest number of that on that list can divide also into 28. So 4 would be the biggest number on that list that can divide evenly into 28. So my greatest common factor is 4. Now again, you could use a table or the prime factorization method, whatever you're comfortable with. Number 24, I have 40 and 45. I'm going to start with the smaller number, which is 40. 40 can divide into 40. 20, 10, 5, 4, and 2. I never include 1 unless nothing works. So you want to use the greatest common factor. So 1 is not commonly an option. Now work from the top to the bottom. You want the biggest number that can also divide into 45, which in this case is going to be that 5. So the greatest common factor for 40 and 45 is 5. Now in the next section, it says to factor, not greatest common factor. However, we do use greatest common factor to help us factor, which means to rewrite as a multiplication problem. So number 26, the greatest common factor of 12 and 16. So again, I'm going to start with the smaller of the two, which is 12. So 12 can divide into 12, 6, 4, 3, and 2. Now the biggest number of my factor list for 12 that also can divide into 16 is 4. So 4 is my GCF. Factor means to rewrite as a multiplication problem. So now I have my parentheses and I'm going to divide each term by the 4. So I end up with 3 minus 4x in the parentheses. So this problem written as a multiplication problem is 4 parentheses 3 minus 4x. Number 28, I have a 10 and a 50. So factors of 10 are 10, 5, and 2. The biggest number on that list that can also divide into 50 is 10. So 10 is going to be my GCF. I'm going to put my parentheses and divide. So 10 goes into 10 once, so 1x. 50 divided by 10 is 5. So it would be 10 parentheses 1x plus 5 or 10 parentheses x plus 5 written as a multiplication problem. And then hopefully by me going over the evens will make the odds even easier for you tomorrow based on where you were confused. The next section is based on lessons 4 and 7. So I'm going to do number 30. It's an even. In order to combine like terms, you first need to distribute to get rid of the parentheses. So 4 times 2x is 8x. Positive 4 times 7 is a positive 28. The 5x comes down, and that's a positive 8x. So I'm going to put a plus in between. Now that the parentheses are gone, I can combine like terms. So 5x plus 8x, and hopefully you're using your calculator for anything you're unsure of. 8, 9, 10, 11, 12, 13, or your fingers to count. 13x plus 28 is your final answer. Number 32 is just what we did in lesson 7 on Monday. You're going to start by putting your 1s in and then distributing those 1s to get rid of the parentheses. So 1 times 3x is 3x. 1 times 10 is 10. 1 times 5x is a positive 5x. And 1 times a negative 4 keeps it as a negative 4. Combine like terms, 3x plus 5x is 8x. And then a positive 10 take away 4 is a positive 6. Number 34, a little bit different because we have the minus in between, so you want to be extra careful with the multiplying. So the first set, I'm just multiplying by a positive 1, so nothing will change. The second set, I'm multiplying by a negative 1. So a negative times a negative, that's a positive 2x. A negative times a negative is now going to make that a positive 7. Now that I've gotten rid of my parentheses, 1x plus 2x is 3x. 8 and 7 gives me a positive 15. 36, translate each expression. Quotient means the answer to a division problem, so I'm going to put my fraction bar. And they want the quotient of a number n and 15, so it's n over 15. Number 38, product is the answer to a multiplication problem of 32 and x. So we just write that as 32x. Number 40, 6 times the sum of x and 3. So 6 times the sum. So you want to make sure you have parentheses because it's 6 times the sum, which means addition, of x and 3. So x and 3 are being added together because that's their sum. And then we're doing 6 times whatever that sum is. So the parentheses are very important there. You're not doing 6 times x. It's 6 times the sum of x and 3. Number 42, $20 divided among x students. So again, division, you want to use that fraction bar. So 20 over x. And make sure you're using whatever variable they're giving you. If they don't specify a variable, then you can choose what you want to use. 44, a painter charges a flat rate of $100. It's the same as saying a fee, plus $20 for each hour. I don't know how many hours, so I'm going to cross that out and put an H for hours. Write an expression to represent the situation. $100 he charges up front, plus $20 an hour, so $20 times however many hours, which in this case I used the letter H. You might have used a different letter next to that 20, that's fine, but try to keep it relevant to what it is that you're talking about in the problem. Number 46 through 51 are review. You could use a calculator if it's one step. If it's anything more than one step, you need to show each step. So number 46, -1 plus 10. You could punch that right into the calculator, or signs are the same, we add, different, we subtract. They're different, we subtract, and we get +9. 48, you have more than one operation, so you really should start by writing PEMDAS. P for parentheses, there are none. E for exponent, there are no exponents. Multiplication and division are grouped together because we do what comes first, left to right. 20 divided by 2 is 10. Now we do 10 times 5, which is 50. And then I suggest taking the whole original problem, punching it in, hitting equals, and make sure the calculator also followed order of operations and got 50. And then problem number 50, we have that dot there, which is multiplication. So you could use your tic-tac-toe board or your calculator. 4 times -5 is a -20. I know that was a lot, but hopefully by going over the evens will make the odds even easier for you for anything that you were confused on. I am re-recording this video after posting all my videos and them not having sound. So this is my second time going over the evens. I do have a question in the Google form that asks, I think specifically about my son and his Halloween costume. So just to kind of go back over that so you can get the right answer to the Google question. I did spend the weekend going back and forth to the Halloween store because my son's costume has not arrived yet. So he did have to pick something else out. He wants to be the Karate Kid from the Karate Kid movie, and those of you that are familiar with Cobra Kai. But now he's a Skull Commander because he had to pick something else out. So he is not happy. Hopefully it will come in time, and hopefully you're still listening and you're going to get the question right in the Google form. Okay, guys, I'll see you tomorrow for odds. Talk to you soon.